Hi everybody, welcome back to Viral Integrals. So today we have this integral. At first glance it looks completely unreasonable. Roots inside roots, logs in the exponents, and no obvious substitution. The clue is that every factor is still a power of x, so we can attack the exponent instead of the radical. Since the factor x outside the radical has the same base as every factor inside, it contributes a +1 to the exponent. A square root divides an exponent by 2. If another root sits outside it, that root divides the exponent too. The first power, x to log x, is only under the square root. That single root divides its exponent by 2. The next power sits under a cube root and also under the outside square root, so both denominators appear. The third power is under the fourth root, the cube root and the square root. That gives the next factorial denominator. The first three terms show the rule. The kth power of log x is divided by 2 times 3 up through k plus 1. Multiplying powers of x adds exponents. The outside factor supplies the leading one. The exponent now has factorial denominators. The nearby known series is the exponential series. The target series starts with 1, then terms with factorials one step lower. First, remove the constant term from e to the u. Now divide by u. Each term loses 1 power of u, while the factorial denominator stays where it was. After subtracting 1 and dividing by u, the exponential series has exactly the same denominator shift. Now set u equal to log x. The shifted exponential series becomes the exact exponent from the radical. The compact exponent still contains e to the log x. Replace that with x. The nested radical and outside factor now combine into one ordinary power of x. But the exponent still has log x in the denominator. Rewrite the base so that denominator can cancel. Use the power rule for exponents. The log from the base cancels the log in the denominator. The whole nested radical expression has collapsed to a standard exponential function. Since e to the x minus 1 equals 1 over e times e to the x, the constant factor can come outside the integral. The antiderivative of e to the x is e to the x, so the interval from 0 to 2 gives e squared minus 1. After the factor comes out, the bracket is e squared minus 1. The answer is not just the outside 1 over e. And now we have the answer. The original integral is equal to e minus 1 over e. Alright, just a quick recap. So, the roots created factorial denominators, the shifted exponential series collapsed the exponent, and the last integral became 1 over e times the integral of e to the x. Alright guys, I hope you enjoyed that, and we'll see you next time.